we will be covering some essential concepts in computer science and programming. Every aspiring coder should know. So whether starting or looking to brush up on your skills, this video is for you. We will be discussing in the key concepts of CS50, focusing on system internals, debugger tools, the debugging processes, and the stages of compilation in the C compiling process. We'll start the exploring how computer systems operate internally, then move on to the understanding debugger tools like GDB and the art of debugging in CS50. Finally, we'll unravel the intricate stages of compilation from pre-processing to linking, shedding light on the complexities of C compiling process. Now let us talk about the CS50 debugger. CS50 debugger is a powerful tool used in CS50 courses to debug C programs. It allows users to step through their code line by line, set breakpoints to pause execution, inspect variables values, and track program flow. With initiative command line interference, it provides features for examining memory, stack frames, and source code. The debugger integrates seamlessly with the CS50 IDE, offering a convenient environment for debugging. It aids students in understanding program behavior, identifying logic errors, and troubleshooting issues. CS50 debugger enhances the learning experience by enabling hands-on exploration of code execution and debugging techniques. This is CS50 code space. I have already created a two files, hello.c and hi.c. This is the code which is there in the hello.c. Let's find out the errors and make the output visible. To do that, go to the terminal and type make hello, and there is an error, so type help 50 space make space hello. Missing terminating as a double quote character. I think so. I'm missing a double quote in this code. Yes, in printf statement at last, and again type make hello. Again there is an error. Type help 50 make hello. Expected a semicolon after return statement. Yes, here. Now type make hello. Yes, here the file created with the name hello. Now type dot slash file name hello. Yes, here is the output visible to us in the terminal. Welcome to my channel. Here, see. Now we can go to the second program. First of all, we can clear this. Okay, then type make hi. Again there is an error. Help 50 space make space hi. Expected semicolon. Okay, again same mistake I have done. Okay, now I can type make hello, sorry make hi. Here created make hi. For output dot slash hi hello world. See, this is the output. Now let's see the C compiling process. First, source code. Your C source code typically has a .c extension. It will go into the pre-processing. The preprocessor processes directives such as hash include, hash define, etc. The output is usually a file extension with a .i extension. Compiling. The compiler translates the preprocessor source code into assembly code specific to the target platform. This assembly code is then translated into object code, resulting in files with a .s extension. Assembly. The assembler translates the assembly code into machine language instructions, resulting in an object file with a.o extension. Linking. The linker combines the object files generated by the compiler with any necessary system libraries and resolves symbols and references between different object files. It generates the final executable binary file, typically with no file extension on Windows. Throughout these steps, various temporary files may be created, including files prefixed with a dot that are used internally by the compiler and linker. These files include intermediate object files, dependency files, and other temporary files needed for the compilation and linking processes. They are usually cleaned up automatically after the compilation processing is complete. Compilation and execution stages. First, pre-processing. In this stage, the preprocessor scans the source code for directives like hash include and hash define. It replaces these directives with the actual code they represent effectively. Create a single cohesive file. For compilation. Compilation. During compilation, the source code is translated into assembly code by the compiler. The assembly code contains instructions that are specific to the target processor architecture but are still human readable. Assembly. The assembly code generated in the previous stage is converted into machine code, which consists of binary instructions that a computer's processor can understand. This process is performed by the assembler. Linking. In the linking stage, the linker combines the machine code generated from multiple source files and resolves the references to external libraries and functions. It produces an executable file that can be run by the computer. These stages together form the compilation process, which transforms human readable source code into machine executable instructions. Each stage plays a crucial role in ensuring that the final executable is correct, efficient, and compatible with the target system. To see the dot extension files, type c line space hyphen save space the hyphen temps space file name hello dot c, enter. Here we can see the hello dot I extension file, dot o extension, dot s files, and the dot bc something. So let's see the dot I file. Okay, first step of compilation called pre-processing. Here dot I file is generated. In this, the lines starting with the hash are interpreted by the processor and the comments removed from the source code. As we can see, hello.c, I gave welcome to my channel. But we can see there is no search line. Also, hash include stdio.h is just expanded at end of the file. We can see our code at last. It is just of 7 lines. See this. This is our code. Next, second step of compilation is .s file generated here. C program is verified for syntax errors is generated into assembly language, and we can see welcome to my channel. Here, welcome to my channel. This is what we want to print after this assembler will translate assembly instructions into object code, which is of dot o file extension. We can open it in text editor or other options. We can't understand its language. See, open anyway with text editor or hex editor. Welcome to my channel is printed after this one of the generated file, and start library file generates the final executable file, which is of a.out. Wait a minute, it's loading. Open anyway. Text editor. See, we can't understand this language. Operating system. It is also called as OS. Serves as the intermediary between hardware and software, managing resources and providing essential services for computer programs. It facilitates tasks such as memory management process, scheduling, file system management, and user interference interaction, enabling users to interact with the computer efficiently and effectively. Example: iOS, Windows, and Ubuntu are some operating systems, and etc. Computer internals. Here, some of the computer internals are there, like CPU, RAM, GPU, motherboard, storage. CPU stands for Central Processing Unit. It is the brain of the computer responsible for executing instructions. GPU, it is a graphics processing unit specialized for rendering images, videos, and animations in a computer's graphics system. RAM, it is a random access memory. It is a temporary storage for data and program instructions. It is a permanent memory for storing the data and files, programs, even when the computer is power off. Let us talk about the system internals. Computer system contains various components including CPU, memory, input and output devices connected to a bus controller. Understanding these components is essential for programming and troubleshooting. It is crucial for computer scientists, system administrators, and software developers to have a solid understanding of system internals to effectively design, troubleshoot, and optimize the computer systems. Now let us talk about the CPU. CPU is the brain of a computer responsible for executing instructions and performing calculations when a program is running. The CPU needs to access data and instructions stored in the memory to carry out its tasks. Memory is also known as RAM. Random access memory is where the data instructions are temporarily stored while the program is running. It's much faster for the CPU to access the data from memory than the other storage devices like hard drives. The interaction between the CPU and memory occurs through a process called fetch execute cycle. The CPU interacts memory to execute instructions and store data. In this interaction occurs through a series of tasks including fetching, decoding, executing the instructions and excited commands shown through the input and output devices. Input devices users interact with input devices to provide commands, data, or signals to computer systems. Common input devices include keyboard, mice, touchscreens, scanner, web camera, microphone, joystick, keyboard. Output devices. Once the computer processes the input provided by user, it generates the output that is presented to user through the output devices. Examples are computer, printer, speaker, headphone, and projector.